Dear students, today we will discuss on Leibniz theorem on successive differentiation. Here, the name of the method, it is named after the famous mathematician Gottfried Wilhelm Leibniz. This Leibniz theorem is a very versatile tool for solving many complex problems in calculus of mathematics as well as for higher engineering problems. Let us discuss some application of Leibniz theorem. First of all, it generalizes the product rule of differentiation. That means, if two functions are differentiable, then their product is also differentiable. So, primarily, we actually apply Leibniz theorem to calculate the nth order derivative of product of two functions, product of two differentiable functions. Besides this, you can widely use Leibniz theorem in finance and economics, and also you can model by using this Leibniz theorem the physical phenomena like velocity, acceleration, force, etc. Let's go into this theorem. So before starting it, first of all, we all know the first order derivative. How to calculate first order derivative, the product of two functions. Suppose y equals to uv, where u and v both are function of x, and its differentiation exists. Then, if I take the differentiation with respect to x, what will come? u1v plus uv1, where u1 is the differentiation with respect to x of u, and v1 is ddx of v. Okay, so up to this one we know. Now the problem is, if it is asked to calculate the value of y10 of uv, what will come? In between these steps, we will get a lot of terms, and it is quite complicated to handle all these terms. Huh? So to avoid this one, we have to take the help of Leibniz theorem. Okay, now the theorem portion. If u and v be two functions of x and nth order derivative exist for those functions, then yn, that is nth order derivative of u, equals to uvn equals to nc0 u and v, nc0 u and v plus nc1 u n minus 1 v, v1 plus nc2 u n minus 2 v2, and at the end you will get the term ncn u vn. What is v1, v2 and vn? v1, v2, vn are the differentiation of v with respect to x. v1 means first order derivative, v2 means second order derivative of v with respect to x, and similarly nth order derivative of v with respect to x. Now you know the expression of NCR, which is equals to n factorial divided by r factorial into n minus r factorial. Now we have to solve some problems by using Leibniz theorem. First example, y equals to x plus sin x, we have to calculate ym. So for it, first of all, we have decided what will be u and what will be v. That means u means the first function, v means second function. Here, we have to be very clever to choose the first function and second function. Why? Because in our formula, we have seen yn equals to uvn equals to unv plus nc1 un minus 1 v1, then v2 up to vn is there. Now, if I choose v like v as x square, what will come? v1 is coming to x, fine. v2 is coming to, fine. But v3 is vanished. So obviously all the higher order derivative of v will be vanished. So our calculation will be more easier. So that's why we have to be very careful about choosing the v and u. Now in place of x square, if we take v as sin x, there is no problem. But we have to write all the time all the terms. Okay. Now in successive derivative, we have derived some nth order derivative of some special function. So when u equals to sin x plus b or sin x, nth order derivative will be sin n pi by 2 plus x. Now coming back to this theorem. UVN. First of all, just write down all the theorem. The theorem is written. Now put all the value here. UN. UN means sin n pi by 2 plus x into v. V means x square plus NC1. The value of NC1 is n factorial divided by 1 factorial into n minus 1 factorial, and then n into n minus 1 factorial divided by n minus 1 factorial. Just cancel it, you will get only n. So NC1 means n into un minus 1. How can I get un minus 1? In place of un, just replace n by n minus 1. We have got un minus 1 into v1. v1 means 2x. Just put here plus nc2. Now nc2, the value of nc2, if you calculate, you will get n into n minus 1 divided by 2 into un minus 2. un minus 2 means just in un replace n by n minus 2. You will get sin n minus 2 into pi divided by 2 plus x into v2. What is v2? v2 is 2. That is 2. That is done now. Now just we have to simplify and rearrange it. Here sin n pi by 2 plus x into x square, it will be as it is, plus n into sin n minus 1 pi by 2 plus x. I mean 2nx will be there, 2nx plus these 2 and these 2 will be cancelled. So the remaining part is n into n minus 1 sin n minus 2 pi by 2 plus x. That is done now. So this is the process to apply Leibniz theorem in any problem. Okay, very simple. Just like this one, we can observe some other examples, like if y equals to x cos x, what will be yn? First of all, we have remembered the Leibniz theorem, the formula particularly. So here the same concept, u and v concept. If I choose u as cos x and v as x, our calculation will be easier. But if we choose u as x and v as cos x, we have to write all the terms repeatedly. Okay. So for this case, for the second problem, we have to take u as cos x and v as x to get our solution. Now for the third problem, if y equals to e to the power x sin x, what will be un? What will be yn? So for it, again we have to choose what will be u and v. If you see, if I take u as e to the power x and v as sin x, if I take v as sin x, what will come? v1 will be cos x, v2 will be minus sin x, and so on. That means after any order derivative, we will get some terms. It will not vanish. So that's why v is, if I take v as sin x, well, but if I take v as e to the power x, again after nth order derivative, it will present. That means after some differentiation of v, it will not vanish. So here is no advantage of taking V in special manner. V in special manner. So here we are free to choose V and U as our own. Next, we have to take another type of problem to apply Leibniz theorem. Here the problem is, if y equals to a cos log x plus b sin log x, prove that x square yn plus 2 plus y 2n plus 1 into x yn plus 1 plus n square plus 1 yn equals to 0. This is our problem. What to do? First of all, we have calculated y1, that is first order derivative with respect to x. It will be minus a sin log x divided by x plus b cos log x divided by x. Then just x has been multiplied in left hand side. xy1 equals to minus this one. Again differentiating with respect to x, what will come? xy2 plus y1 equals to minus a cos log x by x minus b sin log x by x, and again this x will be multiplied in left hand side. So x squared y2 plus xy1 equals to minus y will come, because the numerator part is nothing but the given function. So x square y2 plus xy1 plus y equals to 0. This is our first part of the problem. Name it as equation 1. Next part. On equation 1, we have to use the Leibniz theorem. That means x square y2 whole n, this n equals to this n. Now for the first term, we are using Leibniz theorem. Here, for the first term, again uv constant. If I take v as x square, our calculation will be easier. So, u is y2. So, un v. Un will be yn plus 2, because already y2 has been done. On y2, we are taking another nth order derivative. That's why yn plus 2 into x square plus nc1 un minus 1 v1. So that un minus 1 is nothing but yn plus 1 into v1 means 2x plus nc2 un minus 2. Un minus 2 means yn will come and v2 means 2 will come. So here it is the end of the first term. Similarly, for the second term, we will get yn plus 1 into x, unv plus nc1 un minus 1 v1. Un minus 1 will be yn and v1 will be 1. And for this term, yn will be there equals to 0. Now the simplification. Yn plus 2x square plus nc1, we have seen its value will come in. So 2nx yn plus 1 plus nc2, before we have seen the value will be n into n minus 1 divided by 2. So that 2 and this 2 will be cancelled. We will get n into n minus 1 into yn plus xyn plus 1 plus nyn plus yn. And if we simplify, we will get our required representation as x square yn plus 2 plus x into yn plus 2 into 2n plus 1 plus n square plus 1 into yn equals to 0. That is the end of our problem. Okay, now just like the previous one, if we take another problem as if y equals to e to the power n sin inverse x, prove that this one. What will be our process? The same process, just do the first order derivative. Here, after the first order derivative, it is coming n into e to the power n sin inverse x divided by root under 1 minus x square. So to simplify it, just square both sides. So what will come? 1 minus x square into y1 square equals to n square into the square of this term, which is nothing but the given function y. So m square into y square is coming. Now just I have arranged it in this way: 1 minus x square y1 square minus m square y square equals to 0. Again differentiate with respect to x. Then we will get 2y1 into y2 into 1 minus x square minus 2x y1 square minus y square का differentiation, that means 2y into y1 into m square equals to 0. Now from this expression 2y1 will be cancelled and just name this equation as 1. Okay. Now the rest part, this was our first equation. Now on this equation again we will apply the Leibniz theorem just like the previous problem. For the first term we will get this total expression, for the second term we will get this expression, and for this one minus m square yn equals to 0. And similarly, just do all the calculation, we will get your required expression. So that's all for today.